It's called a flame test. It is one of many experiments that a chemist or a scientist could do when he wants to find out information about the world. There are multitudes of experiments that a chemist can do to learn about matter, because matter has all kinds of different properties, and many of those properties are unique to certain elements, and so therefore you can use them as a way to determine what something is. Now this is called a flame test. It is something, so many years ago, somebody discovered that when you burn ionic compounds, which have a metal and a nonmetal, an ionic compound, that many times they would burn with a characteristic color. And they discovered that this color came from the metal. And so you could actually use that as a way to identify metals. Now, sometime in nature, because of the arrangement of the atoms, sometimes you can see a color change that might indicate a metal just by the color. For instance, on my thing here, I have got two greenish compounds, bluish greenish compound. That is a good indication that this might be copper. You understand? It might be copper. Now, when we burn it, if it doesn't burn the characteristic color of copper, then it isn't. Okay, but because see, and that's how we distinguish it. Just by looks alone, no. We also do an experiment that actually proves it. So if these burn green or blue-green, then we've got copper in these two cases. Oh, what happened to this one? Oh, it's right here. Okay. Good. Where it goes? There. Okay. All right, now, so basically we'll be doing that. Now, once we've done this, of course, that's just the first step. If somebody gave me an unknown, like years ago, somebody gave me this, I have no idea what that is. I'm sure when they gave it to me, they told me what it was, but I should have written it down. I should have put it on the bottle, but I don't remember. All I know, I only know two things. Well, I know three things about it. It has an orange color, so that means if I went to the CRC handbook there, I could look it up. And probably now it's online. I guess I could just type in orange color and then bring me up all the compounds that are colored orange to start with. That would be a real nice thing. As it is, I had to look through that book. Also, I know that it dissolves in water. That was the experiment I did. How hard is that to do? And now so I know it's ionic or at least polar. Okay, and I know what color it burns. All right, which I'm not going to tell you. Okay, so anyway.
Looks like pizza seasoning.
Huh?
Looks like pizza seasoning.
Yes, it is. It is. Would you like some on your pizza?
I mean,
hey. Okay. All right, let's get started now. Nowadays, hey, bud. Nowadays, I do this a little bit different than I used to. I used my baby John's baby spoon that I kept for when he was a baby, and I dip out some out of the bottle and burn it on fire, and that did pretty good, but it did waste a lot of material. Then I decided to find a better way, so I looked online, and somebody was using Q-tips. Wet the Q-tip, and then all you got to do is literally stick it in something. So I can now get by with a whole lot less. I mean, I might burn up this much in just one sitting, right? Hey, bud, I might burn up this much in just one sitting. Okay, so this actually saves something, and it is also less likely to bring the fire department, which is a good plus. All right, now, so let's start with the first one. You will be filling out that paper. Now, on the paper, you have two different blanks. You're going to be using the first blank. It says the flame without filter, the flame with filter, color filter. Okay, now, I don't have the filters anymore. I never did. But basically, here's the problem. Sodium is a contaminant. This is sodium chloride. This is salt. We all know there was a universal flood, right?
I thought you had pure sodium.
We all know there's a universal flood. The universal flood covered the entire world with salt water. And then when that all drained away, a lot of that salt water remained behind as a contaminant on all the planet. If we didn't have any other piece of information than that is a good sign, a good clue, that once the earth was covered with water. Every part of it. Okay, so because of that, we know, like all the others, sodium burns with its own characteristic color. I won't tell you what that is either till we do it. But basically, that will contaminate if it's contaminating a sample. And so that's what the good would be if we had the glasses. So without it, and you have a contaminated sample, you will see maybe a color plus the color of sodium, and that'll distort the color that you see. Other one, when you wear the glasses, and they are literally blue glasses, blue shaded glasses, that actually filters out, believe it or not, the color of the sodium, and you get to see it in its true color. It's almost like those blue box sunglasses you may have heard of. You heard of blue box sunglasses? They're kind of cool sunglasses. So anyway, now, here's the good news. We are using pure chemicals, so that's not an issue. They have been purified. There is no appreciable and cannot be any appreciable hydrogen or sodium contaminant in them. So we will see the true color without the glasses. But I just thought it'd be cool. I tried to make some one day, kind of like those glasses you wear to the 3D theater, right, with a plastic lens. You look at that, not like the modern ones are actually real glasses, but back in the day they were cardboard. When I used to go and everything, they've tried 3D. They've tried 3D movies forever. They just don't work. They even tried smell-o-vision. Did you ever go to smell-o-vision? That's where you go and you see somebody pouring coffee. You smell the coffee, right? All those things were fads. They just didn't go over that well. All right, now let's go ahead and start. What we'll do is, let me light the flame, okay? And we'll get this thing started. And you're going to record. You are the scientist. You are going to record the color of the thing. Be sure you put your name on that sheet. That is your grade today. That indicates that you are here and a participant. So, now we're going to start with, as you see here, lithium chloride. And most of these will be halogens. Most of them have chlorine, bromine, or iodine as the last element in it. Okay, they work the best. There are others that work too, but those work the best. All right, now, so I light it. Okay, I got to remember there is a flame right near my head. Okay, and now notice it is a white solid. Many things in nature are white. Based upon the structure of the compound, they are designed so that when white light hits them, white light bounces off. The others are absorbed because of the shape of the molecule. They absorb different colors, and you see the color that is reflected back to your eye. You don't see the colors that are absorbed. That's the ones that are eliminated from white light. So I wet this thing, I think. I want to put it in here. And this is a unremarkable white solid, lithium chloride. So let's see what color lithium burns. Okay, light. Andy, light.
Light.
Light switch, behind it.
Sorry.
Oh, yeah. Okay, ready? Okay, what color does it burn, guys?
Pink.
Wow.
Red. Hot pink.
Hot pink. Look at that. Isn't that pretty? That is a pretty color right there. Red, very distinctive. Could you pretty much, if you saw that color and something burning, definitively say that's probably going to be lithium? I mean, is there any way you mistake that color? That's going to be a really good positive sign for lithium.
That's a fun
Now,
one.
guys, listen. I'll go ahead and tell you before we start. There will be quite a few of these that are going to be yellow or orange or some shade of it that you'll say, just yellow, another orange. But here's the deal. A real scientist doing this, we're doing this qualitative. That means you're just looking at it. If we did it quantitatively, I'd use instruments to record. And the best instrument to record wavelengths of light is a spectroscope. And so you actually look at a flame through a spectroscope and you see the actual bands of color. In fact, they came up with something called a bar line spectrum, where you look at it through a spectroscope, you take a picture of it. By polarization, you eliminate all the other colors, and it's like a fingerprint. Most of the spectrum from red to violet will be black because they blacked it out. But you'll see a bar here of red, a bar here of orange, a bar here of green or something. And those together make that color when they burn, of the burning flame. And so that is a fingerprint that nobody else had. In fact, that is how we discovered helium for the first time. Helium is a gas. And we did not discover it first on planet Earth. Somebody took a spectroscope and looked at the sun, and they saw the fire, the burning flames. They identified hydrogen immediately because we didn't find that here. But then they found another element that was an unknown element. So they said, okay, what are we going to call this element? Well, we found it on the sun. The Greek word for sun is helios. Let's call it helium. And so that's what led to that. Then later, they found it on Earth, and they discovered what it was, and it said it's actually the second thing on the periodic table, and that is what led them to the fusion reaction that causes the sun to burn. One thing leads to another in science. All right, so that was helium. Now, going on. So a lot of things will burn orange. They'll burn with that characteristic color. Now, let's go to the next one. The next one I see is a bluish-green color. When I actually have it in perfectly clear form, I've shown these before. They're incredibly brilliant blue. They're wonderful color. Now, I suspect blue color. I suspect copper. But let me prove it. Can I prove it?
I give a red.
If it's copper, what do you think it is?
I'm gonna guess a red or a yellow.
You're going to guess a red or a yellow. That's a good guess. Okay.
Green.
Now, if it burns green, it is copper. I suspect it's copper because of the color, but if it burns green, it's copper. What color does it burn? Green. Okay. And you see some reds in there. That may be the cotton burning. I don't know. But anyway. Okay. All right. Light. Thank you so much. All right. Let's go to the next one. Actually, I guess if you keep the light off, you can still see me, but it's okay. All right. Now, the next one is sulfur. Now, I'm only going to do this once because you probably know when you burn sulfur, you get sulfur dioxide. It's got that rotten egg smell, and we don't want that. Okay, now, when I used to do it with a spoon, you may not see it now, sadly, But with a spoon, you'll see the color that it burns, but you'll also see an incredibly beautiful, as the liquid droplets drip off, it's a beautiful color, a beautiful lavender, neon lavender color. But I can't do that now. Okay, so let's do this. All right, so we get, again, I don't want to forget, there is a flame near my head. All right, here we go.
Lights off.
Now cover it with yellow.
Lights.
Huh?
Yeah, just don't hit the lights.
Yeah, when I say, lights, thank you. Okay, guys, watch closely. What color does it burn?
Oh, that's black. Orange.
Yeah, kind of an orange, and it's maybe an orange with some yellow in it, right? Kind of yellowish orange. You're going to see different shades of orange. But like I told you guys, even though a lot of these will be orange, the shade of orange can be picked up by a spectroscope, and it will be a characteristic feature of only one thing. Light. Okay, now the next one, right, is sodium chloride. Now this will be the contaminant I told you about, sodium, right? There's a whole lot of sodium and a whole lot of stuff, okay? And this is good old-fashioned table salt. So now you'll see the color that could potentially contaminate any impure mixture. We are lucky because I am doing known samples. And by the way, we all know what they are, so we know what we're looking for, don't we, right now, right? We all know what we're looking for, all the metals that are here. So this is what you do to start with. You would, to find out what the color is for everything, you take a known sample of something and burn it and see what happens. Then you record that. Then when somebody gives you an unknown, you have a list of colors to go by to look for the right answer. All right, light please. Let's see what color sodium burns. I'm not expecting the world, but let's see what happens. Oh, look at that. Now that is a beautifully yellowish orange, isn't it? Even more beautiful and yellow and orangey than the one before it, right? Again, that's got its own fingerprint with certain shades of color. Remember, the human eye can see, we have red, blue, and green cones. Each one can see 100 shades of color. That's 1,000,000 shades of color. And a spectroscope can see those and give you the exact one. What frequency is that? Okay, light please. Now the next thing is sodium chloride. No, that's not that one. After sodium chloride is the iron filing. A lot of people don't realize that actually metals will burn. I've actually got two on the table that I can easily illustrate that they burn. This is magnesium, and these are iron filings. Years ago, somebody gave me one of my students, one of you guys, gave me a Christmas present. They brought in this metal tin, which has usually got peanut brittle in it or something. You like peanut brittle? You do?
No.
Oh, I don't like this
Gets
stuff.
stuck in your teeth.
I've had it given to me, and I say, thank you so much. And I throw it away as soon as I can. Oh, thank you so much. Anyway, all right, anyway. So, this is actually from a car place where they turned flywheels and turned brakes and drums and all that. And so, this is iron that they swept up off the floor. So, it does have some iron filings in it, plus a little bit of grease. So, that's where your fingers get a little greasy there. All right, so, let me show what happens here. Where can I put it? Let's put it there. Okay, light, please. Okay, now, what color does it burn?
Yo.
That's like a light. That's
Like a light show.
Yeah.
So,
So
somebody,
that's like
hey,
sparklers, that's
people have
all.
asked me, could these be in fireworks? Yeah, sure, why
The
not?
little stick sparklers that you get. That makes sense.
Yeah, and the sparklers could be those two. It's probably some kind of iron-based compound,
a light.
and it will sprinkle and sparkle when it burns. Okay, so that's kind of neat, isn't it? I would call that a bright orange, but it's a cool orange, isn't it? Because it's sprinkled.
Orange with sparks.
Yeah, that's kind of neat. I like that. Okay.
I got a light orange, bright orange, spark.
Yeah. Okay. Next, light on. Okay. The next one is,
That's that blue.
this is cobalt chloride, I believe you'll see. Cobalt, notice what you see here. It's an incredibly, cobalt has two different colors. It is a hydrate. Remember, I've already told you about copper sulfate, pentahydrate, that this is a beautiful dark blue because it has and it's a hydrate because it has water in the molecule, in the matrix to make the crystal. And if you eliminate the water by heating it up, it will become a white powder. It has to have water as a glue, if you want to call it that, to form the crystal matrix. Same thing here. Now, you've all heard of cobalt blue. Does that look blue to you?
Looks a little purplish red.
It is maroon. Yeah, purplish red. Maroon. Exactly. That's what it is. Okay? Now, that's because this is the hydrate form, but when you heat it up, it will become the cobalt blue that you've heard about. Okay? So, let's go ahead and see what happens. Go ahead and see what happens here. I keep getting in the way of that thing.
Don't burn yourself, man.
I know.
We'll pat you down.
I've been spending years growing these eyebrows. I want to keep them. Okay. All right. Now let's go ahead and do this. Okay. I got it covered with the red. The red. Okay, now let's see what color burns. And again, even though it's got a beautiful color, it may not burn perfect, but let's see what it does. Red, cobalt
Blue.
burns.
It's gonna burn blue.
Orange again. Oh no, another boring color. But still, that is a kind of color that the spectroscope can pick out. It's not the same as any other. It has no. But look here, turn it on. Light on. Look what happened. It's no longer red. It's got the cobalt blue. The cobalt blue. Look at there. Look at there. That's like your shirt. Yeah. Oh, like your. Oh, this is exactly like your chest piece. Look at that. Almost cobalt blue right there. Okay. All right.
What was it, orange?
Yeah.
It was orange color. Yeah. One shade orange. But again, at this level, all you can say is it's orange. If you had a spectrum, we could say aha, aha, and you can actually see the barcode spin. All right. Let's go on to the next thing. The next thing is copper, I believe. Copper chloride. Notice again, we have a compound that has a copper color, so that is an indication there may be copper in here. Aha, I think copper.
Yellow.
What do you think? I think copper. So,
Yellow.
It's gonna be greenish blue.
yeah, you think greenish blue. You're probably right. Let's check it out. Now, if it doesn't
Green,
green,
orange.
now it is green in
No, only
color,
green.
but there are a lot of things green in color.
I'm not.
Manganese is green in color. But if it doesn't burn green, it ain't copper.
It's gonna burn green.
Huh?
It's gonna burn green.
You think?
Yes.
Well, I know it is because it's copper chloride.
It's gonna be yellow. Watch.
Yeah. Okay, light, Andy.
Copper on.
All right.
copper on.
What color does it burn?
Yellow.
Whoa!
That's a nice orange.
Everybody
That's
likes
green.
this color.
That's
Isn't
a
that
mint
beautiful?
green right there.
That's green.
It's kind of turquoise.
No,
It's
turquoise.
turquoise. It's changing.
And when it's
though.
turquoise, blue and
Periwinkle.
Huh?
Yo, that was the best color.
Isn't that pretty?
Periwinkle.
Everybody likes that color. That's a turquoise.
Periwinkle. Go like.
Okay, light, Andy. Okay, now.
Is that considered
The next one, guys. Listen, guys. The next one is unknown number one.
I think so.
And I put this in there because it's unknown to me. I said, well, you know what? Let me give them one that isn't. Now remember, the first time I burnt this, since I didn't know what it was, it could have blown up at my face. It could have given off a toxic gas that would have killed me instantly. I could have grown a tail. Not anything could happen right the first time I burned this. Okay, but
I think it's cayenne pepper.
yeah. So, but still, it's orange. Okay. So, and again, only thing I know about it is orange. I dissolved it in water, so it is polar, and that's all I know, which means it's probably ionic. And so I then put this here. Okay. All right. And then I have to. What am I doing? Oh yeah. Now I want to burn it. Okay.
Orange.
What color does it burn?
Orange.
Will it be exciting or just good old fashioned orange? But look at it. Isn't it a bright, brilliant yellowish orange? Okay. Again, spectroscope would tell
Right,
us
brilliant.
exactly what it was. And I survived the experiment. You know? Remember, scientists are the smartest people in the world, likely, probably in the world, and the dumbest. Because they'll do some of the dumbest things on this planet. The guy that discovered that the Anopheles mosquito carried malaria wanted to verify his result. So he took a mosquito, had it bite a malaria patient, and guess how he decided he's going to test it? He let the thing bite him.
No.
The
Smart.
man proved that
Smart.
started out, went in the history books as the guy that discovered the Anopheles mosquito carried malaria, but he died to do that.
That was smart.
You think that's smart?
How else would it
Whatever. Okay.
What was,
All right.
what was the old rhyme? Tommy was a chemist, but Tommy is no more. For what he thought was H2O was H2O4.
That's right. That's right. Some crazy thing.
Yeah.
Also, another, again, you think that's crazy. Well, back in the days when they were studying radiation, guys, all of the early pioneers of radiation research, they're dead. They died of it. Marie Curie, Pierre Curie, Becquerel. I think he may have survived, but Marie and Pierre worked for Becquerel. Okay, so they're studying uranium and all these radiation substances. They have no idea what they're holding in their hands. Horrible, the idea that they had no, well, again, you don't know, you do stuff you don't know. So, but here's the deal. Here's a clue. Maybe I'm doing something bad. Becquerel had a uranium rock, and he carried it around in his pocket for the longest time, right? And then one day he discovered it's burning a hole in my leg, okay? A horrible radiation was right there. So he took it out. Oh my goodness, what an idiot. He took it away. Well, guess what Pierre Curie did? Oh, I wonder if I can do that. So he strapped one to his arm. I mean, like they're the smart people, but also the dumbest. They do some of the
I wonder
dumbest
what it
things.
tastes like.
What does it taste
Like
like?
just eat something.
Oh yeah, eat it and die, man. Radiation's bad enough on the outside, but you eat it, even the weakest particle, the alpha particle, will kill you if you ingest it. Alpha particles can't even get through a piece of paper. Beta particles can get through can't get through a piece of metal. But if you ingest them, they'll kill you.
Right.
Okay? Now, gamma radiation, there is no safe place to be. It'll kill you no matter where you are. Okay, all right, going on. Now, what was that? That was the unknown number one. Okay, now we're going to go to the next one. That is potassium. Now, potassium
Yellow.
chloride. Oh, by the way, something in your sheet says potassium bromide. I couldn't find that. But potassium chloride is still another halogen. You should do the exact same thing.
I'm sorry.
Okay, they have similar properties, remember, because they have similar structure. All right, it is another white solid. So many things in nature are white.
Light.
Huh? Okay, now, what color does it burn?
You said potassium.
Yeah, it's orange again. Okay, no surprise there. Orange again. Okay, now, it's supposed to burn kind of purpley, but it really does. I don't know why it doesn't.
I said pink.
Okay,
Did y'all see it?
maybe somebody lied to me. Maybe it is
Maybe
potassium.
because of the
Hey,
water.
try again. Try again.
Yeah. All right, now, guys, now, by the way, these two bottles here, they tell a story. Years ago, my first year teaching in 1979, I didn't have a lab. My first lab was that toolbox back there. I began to go around to every store in the whole neighborhood of Noonan, Georgia. You name it, I went there. Grocery store, I walked down every aisle looking for stuff, and went to Home Depot, everywhere, and found a different chemical. And so on that day that I went, like a miracle from God, I walk into this drugstore, an Eckers drugstore there, I believe it was, and I walk in, and right in front, they've got a shopping cart filled with bottles of stuff, and it says 90% off. They decided they were no longer going to sell these things in powder form. This could be used for a lot of different medicinal reasons. I'll talk about this later. Old Granny will do this. Okay, so anyway, and they were selling it for dirt cheap. So I bought 4 or 5 bottles of this, 4 or 5 bottles of that, and other things as well. These are just 2 of them that I got, but I also got others as well. But that was the best deal in town. And it was just on the day that on my first year teaching that I was going to go look for chemical. Voila, there they are. Okay? All right, now, we're doing boric acid. Boric acid has boron in it, right? Okay, now, like I'll tell you the story here. Why would it be in a drugstore? Because old Granny, now in my case, my granny, your great-grandma, back in the day, they made up their own home remedies. They didn't go to the store. They gave their son sulfur molasses when they got sick. They gave them this when they needed it. And this, guys, this is an acid, but it's a weak acid. So you can actually mix it up in certain concentration with water. And then when somebody has an eye infection, you just drop it in, and it'll boil out the infection. Get rid of the infection. Old Granny knew how to do that. I'm sure she tried to tell her daughter. Eventually her daughter may have tried it for a while, and then she quit. Today, guys, we live in a ready-mix, quick-fix society, don't we? You can go to the store. I've actually seen where there are boric acid solutions in the store for your eyes. But no, in the day, old Granny would buy this, and this will last her half her lifetime. Those things you buy in the store will not. They're going to run out, aren't they? But old Granny came up with this, and you can still buy it in the store, but now you can buy it already pre-mixed, that kind of thing. All right, now, boric acid. Okay, it's right here. Boric acid, okay. All right, it's another white solid, a powder form. And so this will probably, let me mess up, I messed up. Let me dip this in that. Okay, let's see what color it burns. It's a white solid. It burns. Ready?
Oh.
Green and red right there. Look at that.
Finally.
That pretty color. Green. Lime green. Lime green right there.
Do you think the heat of the fire makes a difference? Like the
Huh?
orange fire?
Oh, it might have some effect. Yes, it might. Yeah. But hopefully we're not seeing too much of that. Now, in some of them I do see where I can see, well, I might be distorting the image of the color a little bit. Okay, yeah. Okay. All right. Now that is, and this is butane, by the way. Butane is a hotter fire than a red fire, right? Blue is higher wavelengths. It's a hotter fire than a red flame, which is a lower wavelength. Okay. So that's why there's different temperatures in the stars. You got white stars. You got red stars. You got yellow stars. You got blue, white stars. All these are different colored stars out there. All right, the light, please. All right, the next one is, I do believe, light is magnesium sulfate. It's another white solid, may or may not give us a pretty color. Magnesium sulfate. Now, you probably have used this in your home. Your mother, magnesium sulfate goes by another name. Its common name is Epsom salt. And you can buy this when you get a cut, an infection on your body somewhere. You can actually dissolve this in water and make it really, really hot, and then stick the wounded part in the water as long as you can stand it, and it'll draw out the poison. Also, on the side of the box it comes in, there'll be a recipe for if you want to actually take a bath in it. And you, so cup in so many cups into the bath water, and then you can soak in it. You know that, guys, in Warm Spring, Georgia, they have those hot mineral springs that FDR, Franklin Delano Roosevelt, President of the United States, used to go down for when after he contracted polio, and while he was President of the United States. Well, anyway, and even before, to be honest with you, basically, they probably have some of these in it, along with other salt. They can draw poison out. All right, so Epsom salt is very good for that. There have been many times I had an infection that just wouldn't go away after days of putting mercurochrome or something on it, that after I soaked it in this, it was gone. Because this literally gets down in there and soaks it all out. All right, so we may not see a wonderful color, but that's okay. Remember, with a spectroscope, a scientist would actually nail this down as magnesium. Let's see if it's orange or whatever. Ready? Eddie? Light? There we go. Okay, now, what we're looking for? What color is that?
Blue.
Kind of a, to me it looks like a pinkish.
It's fighting the flame.
Yeah, what color you see? I see kind of a pinkish color.
Orange.
Yeah, now it's looking orange. Okay, but it was pinkish to start with. And remember, it's the first color. It's the first color you look for. That is the color that indicates the metal ion. All right, now, light please. The next one is, that was magnesium sulfate, so it was a magnesium compound. This is pure magnesium metal. Now, magnesium metal burns, okay? And guys, back in the day before digital cameras, they had to make a flash using flash bulbs. And a flash bulb is nothing but, just like it's an evacuated tube, and they put a bunch of wire that's connected to the little electrodes in it, and then they drop little melted beads of magnesium all over those drops. So that when you put in your camera, there's a battery in the camera, it sends an electric charge through the wire that then lights this on fire, so you can have a good picture of somebody inside the house. Okay? All right, so let's see what color, let's see why they use this. Oh, and by the way, you can also go to the camping section. I've actually bought a bar, a rectangular bar of magnesium. It had a flint on one side for striking it with the edge of your knife. It had the rest of it, you can just cut up. Magnesium is soft enough, you can cut it with a knife. And when you want to start a fire in the woods, you can get together some leaves and twigs and stuff like that, and then peel off or shave off some of the magnesium, and then scratch the sparks into it and start a fire. Okay, guys, let's see what color it burns. Why? I can just look like this. Why in the world would anyone want to burn this?
Oh. It's white.
Bright, brilliant white. Yeah. Wouldn't that make a good flash?
It burnt the red.
And see, it doesn't put other colors. It doesn't put other colors in the mix, does it? Okay? It allows you to have just bright white in a room when you want to take a flash. Want me to do it one more time?
Sure.
One more time.
One more time.
Don't look straight at it.
Okay. I'm gonna try to fold this over into a ring. Yeah. See if I can do that.
that actually, bro.
If I took a bath in Epsom salt like you was talking about,
There we go. All right, ready?
I would turn it to you.
Here we go. Look at that, the eternal flame right there.
It's ET.
That would really make it light in the room right there. And obviously you want to keep it away from fire, it burns really well. And guys, I bought this from the chemical company. That's what this is designed for, to demonstrate a flame test with it. Or the fact that metal magnesium burns.
Do they
All right.
use that material in lights?
Huh?
Do they use that material in certain lights or no? Or what?
So
For what?
for lights, he's talking about lights.
Oh, light, you mean like a film
Like a
commercial light?
Commercial lights. Yeah.
Oh, you would, no, because it burns too quick.
Okay.
Yeah. You
I would
got
guess
it has to
yes.
burn with oxygen.
Okay.
Yeah, see, they use metals like that have high resistance in the field, like tungsten, and then see, it does get super hot, but it doesn't melt, and it does not burn because they don't put oxygen in there.
Gotcha.
If they did, it would break right, it would just pop right away. That was Thomas Edison's first mistake. When he made the first one, he didn't know that, and he put them inside an air environment, and then it would pop real quick. So he said that's when he began to suck out all the air as he was trying to find just the right thing to use as a filament. And believe it or not, the first filament he ever came up with that was successful was a horsehair. Believe it or not. That burned for like a day and a half.
Can you burn my hair?
Huh? Then later they found, horsehair. Then they later found tungsten, and they decided, okay, we can't do what Thomas Edison did. We can't evacuate the tube. Then it'll break when you grab it. So they put a artificial atmosphere of all the noble gases. They do not burn, and so they do not provide oxygen.
Is that what flares are made out of?
I do not know.
Flares.
It could be. You may be right. Could be. I don't know if it's got. It certainly could.
Like the flare guns are like even flares themselves.
Yeah, it certainly could. I don't know what they make it out of, but it is obviously they're making it out of some of the chemicals that exist in nature that would do what that does. Okay, all right, guys, light for just a second. Now we go to the next one. The next one is calcium chloride. Another calcium is a alkaline metal, right? So it's next door neighbor to potassium. Okay, so let's see what happens here. Oh no, it really isn't time.
Let's see.
Bummer. Okay, let me go to the end then.
Oh,
Okay, bummer.
Well,
Just
this
keep
one is
going,
one
just
of
keep
the best.
going.
The end one
Who's
is
the
one
best
of the best.
one? One more.
Is it okay?
We could be late. We could be late.
Yeah, we can be late.
Okay, all
They can
right.
be late for tests. We can
Okay,
go
well, you definitely want to see this one. Okay?
Hold up.
You definitely want to see this one. All right?
The last one. What is this?
Yes.
Strontium
Next,
chloride.
next to last.
Oh, next to
Ready?
last. Never mind.
Ready? Okay, here we go. What colors are burned? Isn't that beautiful? That's pretty nice. Now,
That's a nice gun.
real quickly now, I want to do in my secret vault here,
Oh gosh.
under protection, lock and key.
Pull it out.
We could
Yeah.
be late. It doesn't matter.
Under protection.
I have, this is unknown number 2.
Whoa.
Okay, and I have a measuring spoon. We're going to do this outside because this is what brings the fire
Alright,
department.
let's go.
Oh boy.
Okay.
Field trip.
All right, we're going to go outside, and I want.
What was the one we did? Oh.
Right outside the door. Are you ready? Okay, let's head outside. Yes. Okay, let's come over here. The gas is over there. Let's come over here.
Oh yeah, I forgot our gas is over there.
All right, y'all get where you can
Are we even
see.
gonna see it?
Let's go in some shade.
Y'all ready? Okay, what color does it burn? Oh! That was gunpowder.
Yeah.
Oh, no, make it.
I thought that was thermite.
Good news, I have stolen the key, so I can.
Remember the thing's still on.
Oh yeah, thank you.
Don't let them know that he stole the
It
key.
always puts out the fire. This is how they put out commercial fires like oil rigs. They actually blow it up.
Blew his face off.
I know, bro.
Use up all the oxygen, and
The
that
wind.
extinguishes the oil fire.
What's this as? Gunpowder?
I'm gonna just
Yeah,
say,
it's gunpowder.
like an
Put an
orange.
Okay, come on, you
explosion or
guys.
something like that.
Hey, what's up?
Next thing that you know, you're screaming.